Let's visit another instruction of the tiny machine. We're going to give it a bit of a run-up and do 2 cycles. In this configuration, the instruction pointer is 2, so we need to look at main memory location 2 to see what the operator is. Its code is 5, so going to the instruction table, we see that that is store the accumulator, and it has an operand saying where to store the accumulator. So looking at the program, here the operator is 5 and the operand is 5. In the trace, we should decode the instruction as STA5. Now, what does it do? Well, the accumulator is currently 8, and we should store that value 8 in the location indicated by the operand. That's to say, in location 5. And we should also update the instruction pointer by adding the size of the instruction, which was 2. So now the instruction pointer is 4. And we'll go round again from this configuration with the instruction pointer being 4. Now, if we look in main memory at location 4, we can decode the code for the operator, which this time is 1. Let's go to the instruction table. We see that code 1 stands for the jump instruction. That's an unconditional jump instruction, and it takes an operand which tells us what address to jump to. Now, let's go and look in main memory to see the value of the operand. It comes from straight after the operator, but it is not this 0 which has been overwritten. It is in fact the 8 that we just stored in the previous instruction. So the correct decoding of the instruction is jump to 8. And correspondingly, the impact of that on the registers is just to set the instruction pointer to 8. And that means that we jump over all of this other code and the next instruction is here. So be careful when you have a mixture of storing and other operations that access memory, to make sure that you access the most recent value stored in memory. But you can also see how that's useful for allowing computation to interfere with the structure of the program. This is one thing that happens in von Neumann architectures when you have the program and its data all stored in main memory, is that the program can change itself. So we've seen a bit of self-modifying code, and we've seen the unconditional jump instruction. Let's go round again.